Hi there, welcome to our online video series for Integrated Math 1. My name is Dr. Prince, and I am the High School Math Specialist for Rutherford County Schools. Today we're going to be introducing you to this video series and how the structure of the lessons are going to work. We're going to talk a little bit about growth mindset, as well as mental math, and then what's going to be expected through this course. So we're going to begin with some mental math. And you don't have to do all of this mentally, necessarily, starting out. We're going to talk about mental math a little bit later, but if you would, just go ahead and take a few minutes to see if you can solve these problems. Try to do some of them mentally if you can, otherwise you can work it on paper, but just kind of getting back into the mindset of working mathematically. So take a minute to do that. Alright, so let's take a look at these problems here, starting with number 1. Number 1 says simplify or evaluate 2 to the third power. So we can do that because it is because 3 is what we call a natural number, meaning zero is not included in that, but 1, 2, 3, on and on. So positive integers. Because 3 is a positive integer, then we can think about raising it to a third power as the repeated multiplication definition. So 2 times 2 times 2, 3 times. So 2 times 2 is 4, times 2 again is 8. So 2 cubed is 8. Secondly, we have 75 minus 40. And you can do that a number of different ways. You can subtract 10 4 times. You can take 70 minus 40 is 30 and then add the 5 back in. Either way, we're going to get 35. But there's a number of different approaches there to solving that problem. And then lastly here, these fractions that we're dealing with, I want you to think about divided by 51 as the unit that we're working with. So these are 51sts. We have thirds and we have fourths and halves and those kind of things, but we could have 51sts as well. And think of it as a unit. So we have 18 of them. So we have 18 51sts plus 7 of them plus 2 of them makes how many of them? And it goes back to early elementary school. You have 2 pencils plus 3 pencils. That's 5 pencils, right? Well, the same thing here. We have 18 of them plus 7 of them plus 2 of them. So let's see, that's 18, really plus 9 of them is going to give you 27, not just 27, but 27 of them. So 27 51sts. So we're not going to add the denominators together or anything like that because that's our unit of measurement. We have 27 of them now. It's only when we have unlike things, unlike units of measurement, that we have to get maybe a common denominator or something, like if you're wanting to add a half with a third. It's like adding apples and oranges at that point. We can't do it without finding some common ground with a common denominator. All right, let's move on to number 4 here. 18 plus 9 equals n minus 2. If we want to simplify the left side first, 18 plus 9 is, as we did a minute ago, 27. Equals n minus 2. And you can go about solving this maybe more algebraic way, or you can just think about it. What number minus 2 would give us 27? And so we can get pretty quickly that n equaling 29 would satisfy that equation and make it a true statement. Up next, number 5 here, there are 6 rows of 8 chairs each. How many total chairs are there? That's the basic definition of multiplication. We have this many groups of this many. So in this case, we have 6 groups of 8. If we had 8 rows of 6 chairs, you get the same thing. And so 6 times 8 is 48. Don't forget your units. 48 chairs. And then lastly, we have 6, which is multiply 18 times 5. Without using the standard algorithm. And instead of explaining this myself, I'm going to show you a quick video from the students at Stanford and how many different ways they thought about solving that problem. All right, so hopefully you were able to kind of see the different perspectives there, and that you got 90 as well, and that it's not about speed necessarily. It's about the process and the understanding behind multiplication in that instance. Well, let's talk about the importance of mental math for a moment. We're going to talk about this as we go throughout this video series, using mental math and number sense to think through certain problems. So we start with the importance of it, and that is it helps learning math. If we're good with our number sense and mental math, and we're not stuck on the number manipulation, we're able to learn math better because we're able to focus on the algebra concept or the geometry concept that's involved, the new learning that's happening, and we're not stuck on why was 40 minus 30 10, or why was 3 times 6 18. We're not stuck on that side of things. We're able to dive deep into understanding the mathematics. Secondly, it's also good for when you go out into the real world. Let's say you go to calculate tip or sales price. Something's 20% off. Quickly estimating about how much that's going to be. Also, estimating costs. Let's say you check out at a store with 6 items. You kind of have a ballpark in your head about how much that should be by estimating with the various values involved. And if it's different than that, then you know there's a problem and you need to ask the cashier a question about that. It's also good for things like ACT. The better we are at mental math, the quicker we are at doing certain things, and the better we're going to trust ourselves. Like for example, 5 times 3. Trusting yourself that you know that that's 15, and you don't have to type it in the calculator just to make sure. Because those critical seconds can add up over time on the ACT. And then lastly, number sense and reasoning. As you work through mathematical problems, problems in life, and the value that you get or that somebody else got is totally different than maybe what it should be, you can quickly recognize that and know that there's a problem. And that number sense can be really helpful in doing that. So those are just some reasons for mental math. We're going to continue to work on that as we go. Obviously with some of these in the Bell work, you could have done maybe just in your head. Hopefully as we continue to practice those, you'll get better and better as we go on. So let's kind of switch gears in this intro video to a growth mindset. The mindset that we approach mathematics with in terms of our abilities to do mathematics and the belief in ourselves. So a few things to note about a growth mindset. One is you can learn math. Everybody can be successful in mathematics. It's going to take some time, it's going to take some struggle, but we can all be successful in math. Nobody's smarter than somebody else necessarily. You'll think differently about it. Maybe you take longer to do things, and that's okay. But you can do it. And so I really want to encourage you to believe in yourself that you can accomplish anything, especially in mathematics. Second, there's no such thing as a math person or math gene. We talk about I didn't get that from my parents, or my parents weren't good at math, so I'm not good at math. I want to let you know there's no such thing as a math gene. Like I said before, we can all be successful in mathematics. Don't compare yourself to others. When you get a test back, or when you even take a test, don't compare yourself. How quickly you did it. Maybe you're the last one to finish. That's okay. Some of the best thinkers in our world, in our society, were not the fastest. One of the Field Prize winners, Fields Medals winners, which is the best prize in mathematics, similar to the Nobel Prize. He thought he was dumb in high school because he wasn't the fastest person. But he thought slowly and deeply about the mathematics. And so we kind of need to reorient our ideas around what's good about math and how do we know we're good at something. It's not because we're fast. It's because we think deeply about it. And it may be slower in that ways. And the effort, growth, and perseverance are keys to success. They're the keys to learning. That we're always growing, we're always getting better. And the more work we put in, the better we're going to get. And so if you don't get something, if you don't understand something, you don't do well on a quiz or something, you just don't have it yet. Yet is such a powerful word, and we've got to keep that in mind that we can do it, we just don't have it yet. And then lastly, we learn more by making mistakes than when we're successful. So if you do make mistakes, whether it be in class, an assessment, just know that that's a great opportunity for you to learn. And you're going to learn through that process if you go back and you think about those problems and you make corrections and you think through your mistakes. You're going to learn better than as opposed to being successful. And so just know that and celebrate. Hey, I'm going to learn through this process. So just keep that in mind. So at this time, again, I'll turn it over to the people at Stanford to show you a quick video about more about growth mindset. All right, and welcome back. Hopefully that video reminded us of some things that I mentioned a few minutes ago, that we can all be successful, and that learning math is maybe not all what we learned growing up, and the messages that we hear, and hopefully the messages will continue to change throughout this year as you continue to watch these videos and work with your teacher in class. So along those same lines is we all approach things differently. You might see this pattern and you may see things differently, you may wonder different things. So if you look at this, if you can quickly count maybe how many is in each one, and maybe what you think the next one would look like. All right, so if you look at the pattern here, some of you may have seen, that you've got, you maybe just counted each one. 1, 2, 3 there, 1, 2, 3, 4, 5 there, 1, 2, 3, 4, 5, 6, 7 there, and then maybe you think 3, 5, 7. Okay, maybe the next one's 9, and those are some great thoughts. But there's tons of different ways that you might have approached this. You may have said, okay, I see 2 here and here in the corners, and then 1 here. So that's 2 plus 1. And then you go on to here and you say, okay, I got 2 here, 2 there, plus 1. So you see kind of the legs plus the corner. So here we have 3 plus 3 plus 1 is 7. Others of you may have thought that the pattern number, so this is maybe pattern number 1 or step number 1, is at the top. So we have one star, and that goes along with the first step here. So step 1, 1 star, and then 1 more below it. Up here we have step 2, so 2 stars, and then 3 below it, always 1 more. And then here we have 3 stars for step 3, and then 1 more below that. So it's always the step number up above, and then the horizontal row makes up the step number plus 1. And so the next one, step 4, you'd have 4 stars going vertically, and then below that, on the horizontal row down there, you would have 5, so making that 9 that we thought it was going to be. And so there's tons of different ways to see this, but it just goes to show you that there's all sorts of different solution paths, and we should value those in the learning process, and we can learn so much from each other. Just keep that in mind. As we go through this video series, a lot of the structure of the lessons will look kind of similar to this. We'll start with a bell work, we call it a warm-up here, which may include some mental math, and then we'll kind of get into the lesson, and then we'll have a closure at the end. But some of our lessons will include some short Desmos activities, and so I want to show you what that might look like. So these are going to be embedded in something called Play Posit, which you've probably already seen some things pop up, ask you some questions, that kind of thing. If a Desmos activity pops up, I just want to make sure you know what to do. So you're going to do whatever's on the screen for the Desmos activity, and then unless otherwise noted, that's going to be it. So once you finish what's on the screen, I want to make sure you're hitting the right X here. So you don't need to hit this X here, if you can see my cursor. That's going to X out of this window right here, but what you really want to do is hit this X at the top left, because that's going to exit that whole piece there, and it's going to get you back to the video, and you can move on. So unless otherwise noted, you don't need to go on to the next slide. You don't need to do anything. Just finish that one piece there that is asking you to go through, and then just hit the X at the top left. So I just wanted to make sure and note that. All right, so as we continue on here, we'll finish with this. These videos are going to be embedded in PlayPosit, and there's going to be some other ones that are, instead of PlayPosit with some Desmos mixed in, it's going to be a Desmos activity with some videos mixed in. So there's going to be two different ways that we're going to provide some resources for you this year. But in terms of Integrated Math 1, here's some things that we're going to look at this year. We're going to start with some graphs, and we're going to look at some various graphs and how those graphs can be used to model the world around us. So there's different quantities that are happening in the world around us, and obviously there's going to be some graphs that can be used to model that, and we're going to see that in the next lesson. So we're going to look at some various graphs, all kinds of different things there. We're going to look at repeated addition versus repeated multiplication. So that in some situations in life, things increase by a constant amount. So you're repeatedly adding a constant value every time, whereas sometimes you're multiplying, so maybe you're doubling each time. So we're going to really compare and dive into the difference between repeated addition and repeated multiplication and what that looks like graphically in a table, in a context, so in the real world, and then also in terms of a function. And we'll get into what a function means in the second lesson. So then we'll get into solving linear equations, so solving for values of x that satisfy a linear equation, which you already did one of them, which was in the Bell work when you were solving for n in the Bell work. I think it was number 4. So you've already done one. So we're going to get into more of those in just a bit. And then next semester we'll get into geometry and how we can determine if two figures are congruent, as well as looking at properties of parallel lines, triangles, parallelograms, those kinds of things. And then we'll finish up with some statistics and how we can graph visually one variable statistics and analyze some different things there, such as mean and how spread out some of the data is. Because data, after all, is so important in our world today. So with that, I'll conclude this first video. Hopefully you learned some things today about mental math, growth mindset, and the overall structure of these video series lessons. So with that, I'll say goodbye, and I'll see you next time.